This tutorial focuses in on describing what the tangent graph looks like, as well as all of the inverse graphs of the trig functions sine, cosine, and tangent. Now, with these particular graphs, the identifying is actually just focusing on the period and asymptotes. So let's get started. Go ahead and pause the video so that you can write the two tangent and cotangent graphs. Okay, if you notice, the tangent graph basically has asymptotes, and then in between the asymptotes is the graph, and the cotangent is basically a reflection of the tangent graph. Now you're looking at the cosecant and secant graphs. Go ahead and pause the video while you write what these graphs look like. Okay, and you'll notice again that these has asymptotes, and the cosecant graph, which matches sine. If you notice, it doesn't also have a value at 0. It goes to the right, similar to the way sine does. And the secant graph, which matches cosine, actually starts at a value of 1. That's one of the ways you can tell the difference between the two graphs if they have not been transformed. And again, all of these are in its basic form, which has a period of 2 pi. Okay, now to find asymptotes and periods. You can also find this information on pages 270 through 273 inside of your pre-calculus book. All of these equations are similar to sine and cosine, where we have an a value, tan, and then the coefficient in front of the x or the theta, because remember, it also can be written as a theta symbol instead of an x, plus c plus d. And if you'll notice again, the red dotted lines represents asymptotes, and the period is basically the rotation of the graph to complete. For tangent and cotangent, the asymptotes are found with these two equations, and the period is found just like for both. It's similar to sine and cosine, only that it's divided by pi, because tangent and cotangent, the period length is only pi, not 2 pi. Go ahead and pause the video so that you can write these formulas down. Okay, and then now we have secant and cosecant. Very similar again to tan and cotangent. They have two different ways of finding the asymptotes, but their period actually does last over 2 pi. So to find the period once it's transformed, you divide by b, or 2 pi over b. Now let's look at some example problems. In this one, I want you to find the period and the two vertical asymptotes, I should say. So again, for the period, I first need to identify the b, and the b is always the value with the x. So my b is 1/3. I take my pi and I divide it by 1/3. When I put 1 over 1/3 in the calculator, it will tell me 3, and I put the pi back on. So I just found the period. Now for the asymptotes, I want to find 2, and so I can find 2 by utilizing this formula. And again, I need a b and a c. So my b is 1/3. My c, remember, if I don't see it, if there's no plus or minus inside of a parentheses, I have no c, so the value is 0. So my first one is 1/3 x plus 0 equals 0. I have 0, so it's just 1/3 x plus equals 0. And then I divide by 1/3, so x equals 0. There's my first asymptote, is that x equals 0. The next one is 1/3 x plus 0 equals pi. And again, when I have 0, it's just 1/3 x equals pi. When I divide both sides by 1/3, I get x equals 3 pi. There's my next location of the period. And that's it for finding the period and the vertical asymptotes for cotangent. Now it's your turn. You try to find the period and the two vertical asymptotes for cosecant. Okay, hopefully you got this as an answer. Again, the period or the b is the value in front of the x, which in this case is 1. And we also know we're going to have to use c, which this time I do have 1, and c equals pi over 2. So to find the period, I write, 2 pi over 1, which is just 2 pi. And I'm done. Now to find the cosecant, my first is x, because really I don't write a 1 in front of b, plus pi over 2 equals negative pi. Now remember, for simplifying purposes, we just ignore the pi and act like it's a variable and subtract or add the numbers and then just put the pi back in there. So I'm minusing pi over 2, minusing pi over 2, but really in my calculator I'm minusing 1/2 from 1. And so I get x equals negative 3 pi over 2. And then for the next one, I have x plus pi over 2 equals pi. And again, I'm going to subtract pi over 2. Subtract pi over 2. I'm ignoring the fact that it really says pi just for purposes of figuring out the numbers. And this is a 1, and that's a 1/2. So x equals 1/2, but again, I put the pi back in there. So pi over 2 is my second asymptote. Hopefully you got those two as your answers. Again, there's more practice problems below as well as in your textbook. Any questions, just go see the North Far corner.